Hello everyone, I guess I'm live again. This is day 2 of the Build a Safe Home Masterclass introduction. So I'm talking to you today about the second segment, basically the second chapter of the book, which is an online course, masterclass that I do on Build a Safe Home. And the second section, which has, has 7 chapters in it, 7 modules in it. So the Build a Safe Home Masterclass that I'm talking about this week, that you're getting the introductory course for free for 5 days. So we've never done this before. I definitely want to hear your comments, and I hope you can, it's recorded, so you can watch it anytime during the 5 days, but don't wait till the end because it's an hour to 90 minutes of content. I can't remember if it has Q&A in it actually, but it's at least an hour of content, and it's action-packed. I have lots of pictures, and I know some people have already commented that it was very valuable. I'm giving away a lot of information in addition to my story. So there's quite a bit of my story in there, not everything. If you want to see more pictures of my story, you can check out the duct cleaning webinar, because that is how my story started. Not that that was the first time we were exposed to mold, but in my story, the first time that we actually had health issues that we knew about in our family was because of mold in ductwork, which I didn't know was a thing. So that's the duct cleaning webinar, that's separate. But today we're talking about how to keep our buildings safe so that we don't end up having water damage and mold in our buildings, and that we can build a home that's going to be supportive, that the air quality will be supportive of the immune systems and the health of those we love and ourselves, so we can help take care of our families. Certainly children and the elderly are more affected, so that's really a scary thing. And in my story, it was one of my children that was affected first. We had been exposed to mold many times. I think I grew up living in I had a bedroom in a basement, lower level with wallpaper on the exterior walls. That's a bad thing, just so everybody knows. But so today we're talking about Unit 2. Now yesterday was Unit 1, which was site planning and design. And that one had 6 modules. Very, very important. I'm going in the order of how you should be building your building and thinking about building your building. I would say the one piece maybe that should come first would be the contracts, which is the bonus module for this master class. But in terms of the actual building process, the first thing is the site. And we talked about that yesterday, so you can go see that live video from yesterday. Today, the next thing, once we have a site, we have to be thinking about design and how the design of our building is going to match that site. So every site's going to be a little different, and we're going to build our buildings a little different based on the site that we choose, or the site that is going to be holding our building. Now, some sites you may think, okay, it's really flat, it's really normal. Number one, no building site is actually truly flat. Even a farmer's field that looks really flat will have slope. And that's why we're doing the site design section, and we're going to do some evaluations and topography surveys and find out, where does the water go? And even if it were completely flat, we want to get that water to go away and have it not sitting next to our homes. So design is going to include the site design, which I talked about yesterday, but now we have to think overall about our building. And so there's going to be vocabulary. Those of you in the industry, that will probably be the easiest section. And but for those of you not in the building industry, there's something here for everyone. So if you're not in the industry, this is a lot of high volume, high technology information related to building. I am a licensed architect. I didn't introduce myself. If anybody doesn't know, I'm Cheryl Seco, and I manage the website avoidingmold.com with my team. And so we're offering this free course this week that you guys have obviously, if you haven't signed up for it and you're stumbling onto this video, then get over there and sign up, because you will receive the link to the masterclass, the introductory class, for this week only in your emails. So you have to get it from there. So we talk about the building design basics, and that's going to be things related to, you want to think about which way the orientation of the building is going to be. Where is the sun? Where is the shade? Where are there trees? Where is the ground sloping away or towards the building? Where's the driveway? We're going to have to access it in some way, and how is that going to affect our building? And then there's a lot of vocabulary, so we can communicate with our architects. Hopefully you're hiring an architect, because I do recommend that. And then where there's different phases of design. So know that when we design a building, we're designing it, it's like a sculpture. So you do not design your floor plan. This is what you don't do. You don't design your floor plan and then think you're done, and now let's see what it looks like. So a building is a three-dimensional object that we're going to live in, and it needs to be designed in 3 dimensions, which means that you do different levels of design. So the first phase is usually called schematic design. And we have design development, we have construction documents. You're not going to do construction documents until you've gone through all the design phases. And what I want people to be clear on, and I talk about in this section of the masterclass with lots of pictures, is that we want to be able to look at the whole building. So in the schematic design phase, we need to look at everything. We look at the site schematically, we look at the foundation schematically, we look at the roof design, we're looking at the floor plan, absolutely, because that's obviously how we're going to live. But our homes are not 2-dimensional in a floor plan, so they're going to have a roof that it's going to have a slope. They're going to have windows in the walls, and we want to make sure that looks good. You know, the wall that you don't want to have windows in, you might not want to have facing the front. At least you want to know where that's going to face, and there may be a direction that you don't want to have windows. So what rooms do you put there? So it may be your decision making is reversed. It's not just how you want to live in the space, it's how the space needs to be lived in because of the site that you've chosen. Or maybe you do have views. So for instance, in my house, I have views to the west, and that's my yard. It's gorgeous out there. We put big windows from my living space to face that way, but it faces west. So there's other design considerations that have to be considered related to that, because I'm in Chicago area, and west facing is very hot sun in the summer. So to have a big wall of glass and not want to put trees in front of it because I want to see my view, I had to keep that in mind. So I have big overhangs over that window, bigger than everywhere else. I put in some special glass there that's UV low, that stops the UV from the sun, so my carpeting and my couch doesn't all fade, and or my area rugs, I should say. I never recommend full-on carpeting. But my pillows, you know, all that stuff, you don't want it to be fading from the sun. And then there's the challenges of watching TV. Lots of times we'll have a TV in the space that we hang out with. And so you want to be thinking of all those things in terms of, is the sun beating in? Are you baking sitting there? And how will you manage that? So that was a situation in my house. And then you have south is very pleasant for a lot of really great daylight. So you might want to have a lot of windows to the south. North can be actually really great for offices. So I'm sitting in my office here today in the Chicago area. It's kind of gloomy and cloudy outside as I'm speaking to you. However, I have roof windows, and I have a giant patio door to a balcony that's right in front of me. So my daylight is mostly northeast, which is actually excellent for working and being on a computer, because north light is more diffuse. East light is the morning light. And so by the time the sun gets really hot and kind of something you have to worry about, it's already the afternoon and the sun has moved along. I do have to pay attention though in the morning, because the sun will shine right on my face at certain times of the year. But I have great light for working. If I were drawing, and I do that occasionally, I have great light for that. And so that's facing north. So there are reasons to have north facing. There's reasons to have south facing. East and west too. Some people like to have the morning sun in their kitchen. So that's something else that you can think of. So in the phases, we're going to do the schematic design phase at every level. So I get people showing me their construction drawings, I do consultations for people, and I do second opinions on inspections, and I do review design drawings. And I do collaborate with architects, so I'm on several other teams where the builder, the homeowner, has hired their builder and their architect. They should hire the architect first, and they have their team. And I'm a consultant to that team. So we meet via Zoom, and we talk about the projects, and I'm focused on helping them fast track what they need to know to make sure that this client gets what they need in terms of air quality and moisture management. So I do this full time, focusing on the moisture management piece, and I can tell you it's a full-time job. I'm researching all the time. Things change every day. And as a licensed architect, if I were taking clients and doing all the details of those projects and managing those projects, I wouldn't have time to do the amount of research that I do, even every day. I would describe myself as a perpetual student. So, but on the other hand, the other piece of this is that my family was first affected that I knew of 17 years ago. So architects do have to do continuing education. We have about, depends on the state a little bit, but it's about 12 hours a year that we have to do. And so for the last 17 years, once I knew that my family had an issue that was related to water damage, mold, and obviously building science, I have focused all my continuing education in that direction when I had the opportunity. So I have way more focus in that area than most people who didn't have a reason to study this stuff. Once somebody in your family has their health affected, and it was more than just one person in my family as we went along, and it included me, so, and my husband. And so what you start to do is that, I mean, I'm clearly going to work for free for myself. So I'm up at late at night researching stuff for our own family. And I realized along the way that I have this font of knowledge. I have files of resources that I would be at a loss if I lost them, but they're in the cloud. And I have all these files that I've collected over all those years. And that's what I share with people. And that's what I'm basing this course off. That's what even the introductory course has been. Okay, what are the basics? So in the introductory course, you're going to see something from each module. Today I'm talking about the design. We talked about there's different phases. So what I kind of rambled here a little bit. What I want, and I was saying that what I get is at the end, somebody's showing me their construction drawings. If I haven't been involved from the beginning, oftentimes I'm asking for the roof plan. Where's the roof plan? It's never been done, and the building is done being designed. That should never be happening. And a good architect would never let that happen. Sometimes architects aren't getting paid to do that, and that's where we come into some problems. You do want your architect to do that, and you do want to pay to have them do that. There should be wall sections. So we need to look at the building in the plan for sure, but don't have decided the plan is perfect when you haven't looked at what's called the elevations, which is the wall views and includes the roof and the ground, and then a roof design. And oftentimes, if the plan is complicated, then the roof is really complicated. And we have a lot of problems with roofs that don't drain well because combination, the client, homeowner, and the builder got married to a design that was complicated before they understood what the roof was going to look like. And so then they just have to make the roof work. And that's a disaster. That's a disaster. That's why we have so much mold in homes these days, is that we need to be going through the design like it's a sculpture in 3 dimensions. So we look at schematically at the floor plan, at the walls, at the window location, at the site layout, at the roof. Thinking about also, how does water get off this roof? Then you go on to what's called design development. Design development is the next phase where you are going to be taking it to the next level. So you've done everything at the other level, including foundation, and now you're going to take it to more detail. There's more things to figure out. It's figuring out where the downspouts go and how does that going to look and how big are overhangs and more details. What are the materials being used, for instance? And then we go on to construction documents, which is actually the drawings that are evolving in this process, which are the drawings that you're actually going to build the home from. And I want to caution people that when those are very simple, and it does happen that the client or sometimes there's no architect involved, thinking, well, we'll save money and we won't draw those things because the builder knows how to do it. We don't need to draw it. Well, unfortunately, that's where we're getting into a lot of problems because codes change, best practices change. As architects, as licensed architects, we keep up on that because we have to. We do all that continuing education, and you want to make sure your drawings are keeping up with all that. And there may be things that your builder is not aware of that you're going to want to have done differently. And so that's where I come in town. I come into play as a consultant with your building project as well. But the master course, the Build a Safe Home Master Course, is ideal. It's the most affordable way that you can listen to me talk for 6 hours of the content, and then there's, I think, 14 hours or more of Q&A sessions and other things that we've hashed out that have come up along the way. And we do come together. The next one coming up is December 29th. So I do come together with the students in that course on live videos. We answer questions. You can submit your questions in advance, and then I make sometimes I just can answer them randomly, but most of the time I'm making some sort of a little presentation with those when I have them in it with enough advance notice, and then that gets recorded. So you can join us on the live call and discuss it, or you can, you'll be able to see it on the recording, and I'll be referencing whatever it is that you had submitted. So that's how we've been doing it, and it's working out really well. We also have 2 ways to communicate in this group. We have the Facebook group, which I'll be honest, I have a lot of people following me who aren't on Facebook. Now, of course, if you're watching this, you are, but we have people that don't want to be on Facebook. And so we have also an alternative membership site, which is the Dwell Well Institute, which we've started, and there you do get a 3 months free membership to there for support for the course as well. And that's really affordable. Anybody can join that. But that's a way that I can really be focusing on putting in content regularly. It is a subscription based, but we post a lot of content. There's some really good people in there that are also commenting. I'm focused on it because it is a subscription based thing. We're hoping as the numbers grow, and they are growing, and I do think those of you in there are ready for being in there. We're getting back to our roots of doing smaller group stuff, which I really enjoyed. Our Facebook group, Avoiding Water Damage, Mold, and Toxins, is over 5,000 people in it. And honestly, I can't keep up with it. There's too many. When I get on, there's already 40 comments on a post. Some of them aren't correct, the answers. And so some are good. There's some good students that have been in my courses that are sharing good information, and I thank you if you're one of those. But there's also people selling stuff, all the usual stuff that happens. And I sometimes get in there and there's all this misinformation, which my goal has always been to share quality information and science. So you're going to go through all these phases in the design, and then we talk about design styles. So that's important, that you want to love what you're going to build. We do talk about floor planning, and there are things that can make a building less expensive, more efficient in terms of floor planning, where you're going to put a mechanical room where your plumbing is going to be. Grouping plumbing together can be a lot less expensive than having 3 bathrooms and a kitchen all in different corners of the building. So we want to think about how this gets built and try to be as efficient as possible. And then there's electric and heating, ventilation, and air conditioning I recommend being designed along with the floor plan and the roof plan and the site, because that in particular, and the plumbing, it's a good idea to have that being included. So, especially the heating, ventilation, and air conditioning, because there may be decisions that we make about our floor plan, our roof plan, our elevations that are based on being able to heat, cool, and ventilate our building well. So there's a lot of mistakes happening to our buildings which is causing mold, which have to do with air conditioning primarily, sometimes heat, but mostly air conditioning. And that's because the air conditioning and the heating system overall is an afterthought. The building's been designed, they're ready to build it. Sometimes they've already built it, and then they've already built it, and now we're trying to put the HVAC in it. So that's all in the design module. And let's see, what else can I tell you about that mine? So I just want to be clear. We're talking about the Build a Safe Home. I hope I'm not confusing you that I have other memberships and stuff out there. We're talking about the Build a Safe Home course, and that is my premium course, and I am very proud of it. So I just want to make sure that that's clear. So we talked about floor planning, we talked about walls and roofs in the design, because that's where you start thinking about those things. We got to think about what kind of windows, where they're going to face, what kind of materials we're going to use. That all happens in the building design phase, and then of course electric, plumbing, and heating and cooling. So that's what I have on building design. Tomorrow we're going to go into foundations. There was a mistake, I'm so sorry, on the planning, in that we had foundations and building design mixed up. But I'm going through the master course, the way that you're going through that you would go through it if you're in it. And I go through it as though you're building a building. So this introductory course that you're going to be taking, if you haven't already, is I have one thing out of each one of these. And so great information, a lot of free information. And then tomorrow I'll come on and we'll talk about foundations a little bit. And so yeah, if you have any questions about what we're doing or this topic or building mold safe in general, feel free to put them in the comments. I will check when you're watching the recording to see if I can find anything. Let me see, I think there are some questions that I might have not seen that my assistant, Crystal, who I could not do anything without Crystal. My assistant's name is Crystal. I have a couple assistants, but she is the brains behind everything tech, for sure. And many of you have gotten her assistance along the way. Let's see. So there was a question about my husband and I are starting to build several buildings up in the mountains of North Carolina at 3,000 feet. We'd like to know what kinds of materials or methods are best to keep mold at a minimum. Materials to avoid, putting up a metal barn, which may not be ideal, but we need a workshop. And we need to know what to frame in one part of it, insulate it with. And so the one thing I want to point out, the reason that this masterclass is 6 modules and the master course is 6 modules, is that this is complicated stuff. Oftentimes there's an effort to just say, well, what materials do I choose and put it all together? Well, this is a little bit like baking a cake. Well, what material, what ingredients do I need to use to bake the cake? The cake is going to be done a certain way, or it doesn't matter what materials you use. It either won't rise or it won't be tasty the way it's supposed to be because you didn't do things in the proper sequence. So any material can be done well or poorly. Some materials are harder to work with than others. I do talk about materials in the course, but know that any material you can use anything. I obviously am always trying to do low VOC materials, low off-gassing materials. That's a good idea. Metal in particular, and concrete sometimes. The materials that are more conductive of temperature can be more difficult because the insulation, they don't have inherent insulation. Wood has inherent insulation. But there's definitely, especially metal barn type facilities that can be done. It just needs to be done correctly, and we need to do some air sealing, and we need to watch out for condensation. So I do have other courses where you can learn more about condensation. But in terms of the materials, know that you can do a really great material wrong very easily. You can also do it right. And so that's what I'm talking about. I'm talking about the materials as a system. Just because you have a great material on the roof and a great material on the wall doesn't mean that they work together well. And that's another piece, plus your climate. So there's some places, especially in the South, I'm more cautious about metal because it basically kind of, if you put it, you could fry an egg on, inside of a coffee can in some of our really sunny climates in the summer because it's very hot. And so if you're going to have a metal home, you're going to have to be really cautious about heat gain. That'll be something to think about. In really cold places, that metal can also be very conductive of cold. So if you think about if you're going to go watch a soccer game or something, and maybe it's this time of year you're going to go watch football. What kind of bench do you want to sit on? It's cold outside. If you're watching this game outside, do you want to sit on a metal bench? Do you want to sit on a concrete bench? Or you want to sit on a wood bench? They're all possible in a stadium, but they're going to have a different feeling for you. So concrete and steel conduct temperature way more. That can be an advantage in some situations. It's definitely related to concrete in terms of passive heat or passive cooling, and that's something that I talk about a little bit in the building design section, because they store heat and cold. But any material can be used well and poorly as long as it's a good quality material. If it's a complicated material to use, or if it's going to be difficult for someone to do it well, even though it may be a good material, then your chances of success will be less. So I don't like to ask people to use materials, contractors to use materials they're not comfortable with. That usually doesn't end well. It's best if you're not teaching someone to use a material for the first time. The other thing with materials that I would caution people about is that new materials are not often been tested enough, that there could be things that go awry, or there could be unintended consequences that come up related to that material that aren't anticipated because it just hasn't been used enough. So UV from the sun can degrade materials. So I can think of a case where there was a really interesting roof shingle. It was made out of tires, old recycled tires. Seems like a great idea. Get all these recycled tires, let's turn them into roof shingles, and people put them on their homes. It was a great selling point for sustainability and recycling. But what ended up happening was that whatever they did in testing, they had to accelerate aging in a laboratory, and that was not going to be the same as what was happening in real life. And so these roof shingles actually degraded from the UV of the sun very quickly, and the roofs failed. So what happens in that situation is a company's warranty is only going to be as good as the company is around. So if the company started up to make this product and then they are faced with this product that they make that now has a defect, they will go out of business. And so your warranty, you have no warranty, even if it was worthwhile. And always read the details on your warranties, because most warranties are not very helpful, actually. But you get nothing if the business goes out of business. And so if the company that made the product goes out of business. So I'm really cautious about using materials that don't have a track record. So that would be the other thing I would say about materials. I have done it. I have done some materials on my house that I'll never use again, honestly. Well, I tried them. It seemed like a great idea, but I'm not using them again. So those are the things to think about related to materials. I don't know if there are other questions. I'm trying to figure out, because I'm using my phone, I may not be seeing everything that Crystal, if you can hear this, you can post I can see your Facebook Messenger. So I don't know if I can see anybody else's comments. I don't think so. I'm just looking at my website. But we've been on for a half an hour, and I think that's enough time for anybody to listen to me talk. And Jeff's asking any suggestions for finishing a concrete basement floor, type of breathable sealant. I think generally you want to use the right product for the material. So there are certain products that are made for that. Again, I would be looking for products that have been around a while. But actually, I don't know that it matters if it's breathable. There's a point where if the concrete needs to be dry, and there will be requirements in the installation instructions on when you can do that and whether you should be testing the moisture content in the concrete. If we haven't focused on the site design, we can have flaws in the drainage around our building that can impact the slab, whether it's a slab on grade or a slab in a basement, and that can push sealants off. So you want to know what are the requirements for the sealant. I'm not aware of very many sealants that are actually breathable. but I'm sure there is something. But the bottom line is that we want to keep the concrete from getting wet. We want to put a vapor barrier under it to begin with. And so that hopefully the only thing that we're going to have to worry about is the concrete curing itself. And one tidbit I can leave for those of you who have been on here this whole time is that concrete takes about close to 2 years to dry. It's about 30 days per inch, not including if it's gotten wet in the process from rain sitting on it and whatnot. So what I'm finding is that in the new construction that I review, that homes that have finished basements that were finished before 2 years are having a lot of mold behind the surfaces that were put up because the concrete, and I would attribute it to two things. Concrete wasn't cured completely before they started finishing it. So there's a certain curing is drying. The concrete comes out from the truck wet, gets poured, and it's got to dry. And so in terms of building design, you want to keep that in mind. Of you can do the interior walls or whatever, but on the exterior walls and the flooring, you also want to know, is your design working the way you intended it to work, so that you can see it through every season. And ideally, if it's 2 seasons, if there's an anomaly one season because you had a lot of water or a little water, you'll see something different the second season, but at least one time, but I would say 2, so that you can actually see, whoa, we are collecting water over there. We did everything right, which is, this happens. You can do everything right and something else gets in the way and isn't perfect. And so, but you want to see that. So Jennifer is asking, what if you're on a concrete slab with wood floors glued down, for instance? Should that concrete have been down for... yes, I mean, this is, so usually wood floors, talked about this a little bit yesterday, wood floors, their instructions for putting them down on concrete are usually going to say that you have to have a vapor barrier or seal the floor before, because the wood floors will warp or they'll degrade when they're in contact with water. And so the flooring instructions will usually tell you in the installation instructions of what they need for the floor to perform, which may not be what you need for the air quality to perform. So putting down a vapor barrier on top of concrete that needs to dry isn't going to work. I guarantee that's not going to work. It will protect the floor. And that's all the flooring installation instructions are worried about, is protecting the floor. What happens over time that I think is an unintended consequence is that moisture is drying, gets trapped under the vapor barrier. There's dirt and dust there. As much as we'd like to think it's sealed, it's not. You know, so there's always going to be gaps and ways for air to get in and out of there. And there's some very strong building pressures that are part of designing a building that I do talk about in the master course, that have to do with how our buildings get wet and how the air moves through a building that we have to consider. And it's complicated stuff. Just like our bodies are complicated. The leg bone's connected to the knee bone, you know, all that kind of stuff. So in a building, it's the same way. And as soon as you turn on an exhaust fan, and that's something that needs to be designed, how are we ventilating the rooms that need to be ventilated as expeditiously as possible? And where is all those pipes going? And how far do they have to go? I've seen homes that were not, the thoughts in design weren't considered, where the dryer's in the middle of the house and has to go 25 feet to get out the wall with elbows, you know, right and left and up and down. And there's no way that a regular dryer has the fan speed to be able to push that air out. So either you're going to have to design an inline fan to be in there to help move the air out, or someone's just going to put it in and it's not going to work, and we're going to have moisture collecting somewhere in your home because you're actually not able to get it out that far. So those are the kinds of things that we talk about in the master course, in the building design section. All those things, that's in the mechanicals piece module of that. And so there's a lot to think about. So if they didn't put on a barrier, Jennifer's saying, let me see if I can read this. It's likely for moisture. I don't know if I can read the whole, I can't read the whole. So they, yeah, I mean, there's moisture in the ground. if they did a great job with a vapor barrier under the slab and you have perfect drainage, which is really hard to do, but it's possible. I think I've done it on my house. If you have all those things done well and they stay well, this is the challenge. Things can be done well, but that doesn't mean they're going to stay perfect. Just like our bodies, you know, we can be running down the street, jogging, feeling great, and then you step in a pothole or something and you know, sprain your ankle, or you fall and you trip over something over the curb, which is something I've done, and now you're all scuffed up and you have scrapes and bruises that you didn't have 5 minutes ago. The same thing happens to our buildings. Stuff happens. So whether it's a wind event and where we can have pieces of our building blow off, we can have animals invade, you know, where they get in and they do damage. We can have situations where there's ice that can do damage. And sometimes it's just the normal aging process. Most of our materials don't last forever. So I am trying to see if I can see these questions. Any suggestion? Okay, I saw that question about the basement, but I know some of you had some other questions. I'm having trouble seeing them. I may try tomorrow to go live on my computer. Actually, Facebook keeps changing things and I can't figure it out. So Crystal is feverishly posting some comments in here so you can see more about the course. So this is just, this is my way of coming on to answer some of your questions as I can and let you know about the Build a Safe Home Masterclass, because it is, I am so proud of it, and it has what you need at the best possible value. Then if you need to even work with me one-on-one, watching that and deciding you're going to have an appointment with me and you're going to watch, you know, a couple modules. Some of the modules are anywhere between 5 and 20 minutes. So it's really easy to move through. But even if you're going to bring me on to be a consultant with your architect and your team, I recommend getting this course and making appointments with me kind of virtually, that you're going to sit down and you're going to watch a module or you're going to watch a section, so that when I come on, you're that much farther ahead, and it's not necessary for me to explain all that at my hourly rate when you can have it much more affordably in the recorded version. Plus you can go back and listen to it more than once, over and over. You can watch it anytime you want. I watch videos sometimes while I'm in the kitchen cooking or doing laundry, and then if I miss something, I go back and watch, you know, the picture, or I pause and then kind of look at what I want to look at. But you can listen while you're driving. Just don't look at the screen if you're driving, but you can listen. So the full course is not the master course, or the full master course is not what you're getting for free this week, just so you're aware of that. The full master course is over 6 hours of content and another, I think, up for 12, 14 hours of recorded Q&A that are presentations with pictures. So that we couldn't even do in a week. It's a 6-week course. I would allot 6 weeks to go through it. So that won't be happening in 5 days. The introductory course that you're getting for free is robust. And so I go through one section, one example of each module of the master course in the introductory course. So that's what you're getting for free. There's a ton of content in there that's going to be valuable. Just know that there's more of that in the master course, lots more. And if there's any architects watching this, you can get continuing education for it. So it is that robust. And even the introductory course I have offered for CEU credit through both the AIA and the ALA in the past. So it's good stuff. So make sure you're getting in to watch the recording this week. Make sure if you are not on the list that you get on the list so you can watch it and access it. And thanks for watching. I will see you tomorrow where we're going to talk about foundations. So thanks for being here, and I look forward to seeing you tomorrow. Bye.